Have you ever tried mixing oil and water and no matter how you shake, they don't just mix? Today we're diving into the science behind this kitchen mystery. Hello everyone, welcome back to my channel. If you are new here, my name is Ima Best. I share kitchen experiments, fun science tips, and cool ways to see chemistry in everyday life. Why do oil and water never mix? Oil and water are everywhere. In kitchen, we use it in cooking. It's also used in science experiments. But have you noticed they always separate? Understanding why is not only cool. It helps us in cooking, cleaning, and even environmental experiments. Look at the water molecule. If you look at the structure, you see an oxygen atom. You have one oxygen and two hydrogen atom, and the oxygen is carrying a negatively charged ion, while the two hydrogens are carrying positively charged ion. It means that oxygen, that's so electronegative, yeah, so it pulls electrons from both hydrogen atoms to itself, so that makes it negatively charged. The two hydrogen, you see a positively charged ion on top of each of them. All molecules, on the other hand, they don't have any charge, they are neutral. And when you look at the structure, the chemical structure is very complex. It's just a mix of triglycerides. It's not just one structure, and they don't have any positively charged ion or any negatively charged ion, so they are neutral. That makes them non-polar. And in chemistry, there is a rule that says like dissolves like. So polar dissolves polar substance, yeah, while non-polar substance dissolve non-polar substance. So since water is polar and oil is non-polar, they just don't mix at all. They cannot mix. It's like trying to force a magnet and a balloon together. It doesn't work. It just don't work. So let's see it in action. Yeah, just watch carefully. I'm going to add oil. I'm going to add oil to water, and no matter how I shake it, they will not mix. You will see the oil on top of the water. Yeah, it will float on top. The water will be down. That is just because their molecules don't like each other. That's all. So just watch carefully while I add. Chemistry is not magic. Yeah. Look at it. See the oil. The oil is on top and the water is down. So right now I'm going to shake it. And there's no amount of shaking that will make them mix. They won't. They won't mix. Their molecule doesn't like each other. Yeah. So. They won't mix. Look at it. See the water down. The oil is still on top. Yeah, some people add food coloring agents. Yeah, they will add it to the water before adding the oil. Yeah, just so that when you shake it, yeah, it will give you a clear view of the water. But I didn't do that. I just used ordinary water. Yeah, look at it. So another reason oil floats is density. Yes, water is heavier than oil. Yeah, that is why the oil floats on top. Just look at it as feather floating in water. That is just the same idea. So this is the oil water mix. Yes. So I'm going to carefully add the dishwash soap. This is my detergent. What we normally use in washing our oily pans here in the kitchen. You see? So what happened here is that the soap molecules have both polar and non-polar ends, which makes them mix temporarily. Yeah, this is it. So let's recap what we did. Water is polar, oil is non-polar. They don't mix. Density makes oil float. And with a little soap, we can bridge the gap. So next time we'll explore more kitchen chemistry, like why washing soda changes the color of palm oil. Stay tuned.